Hello, everyone. We're actually going to start banging the dot because there's so much to fit into session 4AL, what it would look like if we migrated to Git for zOS applications. The presenters are Joe Taff-Atkins and
Dennis Bem.
Thank you, Dennis Bem. Please enter any questions you have in the chat. Dennis is going to be looking at that and keeping on top of the questions. I'll keep on top of the waiting room, Joe, for people. There are a few people that are coming in now, but why don't you crack on, because there's a lot to cover, and go for it.
Thank you very much. So good morning, everyone, and thank you for attending this session. And Stuart, thank you for having me. So my name's Joe Taff-Atkins from IBM, and today I'm going to be showing you what it would look like if we migrated to Git for zOS applications and artifacts, using all the tools that you can see on the slide there, and essentially have a common tool chain across all platforms. So the question is, why is that important? Well, there's a common misconception that you have to have a platform specific SCM and toolchain in this hybrid multi-platform application era that we're in right now. When that's not the case, you can have an enterprise SCM and toolchain, not just to reduce cost or potentially to reduce cost, but to improve your practices in the mainframe space and have common efficient practices across all platforms and languages, and to essentially grow your skills or grow the skills of your existing mainframe staff to more common tooling in the industry, like your Jenkins, like your Jiras, and like obviously the different flavors of Git. And to those of you who are not aware of, well, quite frankly, Git's dominance in the marketplace, I mean, the last figure we were discussing, I think, was Git has an estimated 70% of all SCM usage worldwide. So allow that to sink in for a moment. That is a huge market share. So actually, I remember when Git was sort of flavor of the, well, it wasn't really flavor of the month, but it was a talking topic when I was at university around, I think it was mid 2000s. But now it's just blown up and it's become almost flavor of the last decade, I would say. So yes, this is a presentation via vendor on some IBM tooling and some open source tooling, but I strongly am passionate that I think it's more than that. I think it's a way for us to now keep our platform relevant and no longer different to the cloud space. And now we can start to attract, from this presentation, you will see we should be able to now start to attract next generation developers who are used to doing things in a certain way, with more efficient practices and tools. And it's been proven in the industry. If you think about Amazon's and Netflix of this world, they're delivering code in seconds, and they've got Git as their development tool, and they're using a whole raft of these modern tools to deliver faster market. So I think it's now an opportunity to bring those type of developers to our platform. And are we the only ones pushing Git? Absolutely not. I think every mainframe ISV, maybe bar one or two, are pushing clients to Git. And even Microsoft, Git replaced Microsoft's proprietary SCM, TFS, and Microsoft has moved, if not all, but most of their development onto Git. I think the last figure I saw was 3,500 of their Microsoft Windows development resources out of 4,000 are now using Git, and that was in 2017. So this presentation is really going to be looking at what would it look like if we were to completely migrate to Git for development in our world. So long-winded intro, but I just thought it was important to kind of set the scene and provide a bit more context to this session. So I'm going to talk about why Git. I'm going to talk about why Git in the context of, you know, something we all know and love, like mainframe SCMs, and just trying to highlight some of the differences. I'm then going to talk about a Git overview, just make sure we all level set on what Git is before we go into explain about Git on zOS. And then after that, I'm going to talk to you about why we would need a tool called IBM Dependency-Based Build, and then what is Dependency-Based Build. And then the last part of the session is I set myself a challenge. I've got a lot of friends who are, you know, cloud native developers, although they don't like to be called that. But a friend of mine he's a Ruby on Rails developer, I asked him, show me your current development practice from requirement to production. And I've taken that practice and with a few tweaks and going to show that working in a mainframe context, right? So what I'm hoping to achieve in that session, and it is going to be a live demo, so hopefully demo goes on my side, but it's to show you that we can have a common practices, obviously with small differences, but we can have common practices across different platforms and languages. For Q&A, please ask questions in the chat. I have a colleague who will be answering those questions during the session. So why Git? So I think traditional mainframe SCMs, like your SCLM of this world, of the, you know, and the others out there, they manage traditional Z artifacts really, really well, right? And when it comes to longevity, I think these mainframe SCMs have stayed relevant for decades compared to other SCMs out there in the distributed space. The flip side, though, is that we are now in the modern world with more efficient ways of working, you know, new types of artifacts, especially in the mainframe space. If you think about REST APIs, automated testing artifacts is another thing. Ops dev or infrastructure as code has become a very, very big thing. This idea of provisioning middleware through code, essentially. So Ansible playbooks, if you've heard about that, or zOSMF workflows. So all these new things are coming into our world, and I think these modern artifacts, they're not easily managed in these traditional mainframe SCMs. Now, does that mean we blanket all these mainframe SCMs as old? No, definitely not. But I'm just proposing the idea that these mainframe SCMs that we hold very close to our heart are not always fit for purpose, depending on your business goals and your objectives. And why is that? Well, it was designed for development, you know, several decades ago, right? Where there was more waterfall development and more focus on pessimistic locking. You know, each dev stage in the life cycle is tightly connected to test environments, where you might ask, well, why is that an issue? Well, it makes it hard to adopt this whole industry practice now of giving developers their own sandbox and workspace to, you know, do early shift left testing, where they can, you know, spin up their own environments, do short-lived environments, do this kind of shift left early dev testing scenarios. And you've got several different development activities in these fixed routes to live. You know, you've got short-term releases, you've got long-term releases. And if you get an emergency fix comes in, you know, it leads to bad practices and potentially have to back out changes and so on. And there's limited support for parallel development. You know, there's no option to branch out with sophisticated merging capabilities without, you know, some sort of heavy involvement from your library manager. But that said, in the cloud space, they're able to check out components, right? And actually do test-driven developments. They check out their own component or an application component into their own short-lived branch, do test-driven developments. They're updating their tests, you know, building their code, running the test case against their code, getting code coverage results, and then, you know, pushing that code back to a release branch. And there's an automated pipeline to test that package, and then they're scheduling that to production. So there's no several stages to get to production. It's just, you know, they've got the flexibility to branch out into their own short-lived branches. sorry, probably would be nice if you saw that slide, part of the slide. So the point here is that I just think, there's a lot more freedom, a lot more flexibility to branch out, and that power is given to the developers, and it's a lot more parallel development support when you're using a modern SCM like Git. Obviously, Git is not as a decentralized SCM, but when you use it as a centralized SCM, then you get a lot of capabilities in terms of merging and parallel development support. So the real question is, why can't we have this in the mainframe space? Can we have an SCM that manages both modern and traditional artifacts, that improves practices so that we are in line with the cloud native development space, and that will help us to attract new developers to our platform, and help us to build automated delivery pipelines with a lot of these modern tools out there? Well, the answer is yes, we can. And at the heart of that, yes, we can, is having a common, well-established SCM like Git. So what is Git? So Git is essentially an open source SCM that is used by many universities, many companies, including IBM. So we use Git, and I would certainly, I'd probably say it's definitely helped in terms of attracting new blood to our development organization. It originated in the distributor space, but now we and our partnership with Rocket Software have extended this out to mainframe artifacts. And I think that the key difference from your traditional library manager is that you're not checking out individual modules. You're checking out configurations with support for branching and support for merging, and that's all can be controlled by the developer. And a configuration, as you can see on the chart here, at least in the mainframe context, is a list of all the artifacts. Could be both traditional and modern Z artifacts. So your JCL, COBOL, APIs, test suites, and all of those are stored as part of an application component or an application, and that that's all stored in a configuration. And these configurations are stored in what we call repositories or Git repos. So you may have heard of the term forking the repository. So that's essentially like a checkout in Git or a retrieve in Git. So all of the source in that repository is then cloned to your local branch via a modern IDE, so that you as a developer can develop and test with autonomy in your own environment, whether that's a Red Hat workspace or mainframe on your DevLPAR or your own local sandbox environment, whatever. But that source code is on your local machine. Now, in the mainframe world, we have huge, monolithic applications. So forking the entire, mortgages application is not recommended. Plus, it would just probably take a long time. So if you do want to use Git efficiently for, application modules in general, you do need to find a way to carve the beast and componentize your applications to some degree, but, before you move into Git repositories. But that said, I have heard some cloud native, some of my friends who work for companies who use Git, who've got 10,000s of modules in the Git repository. So there is some analysis and some thinking that needs to be done before just using Git. But on top of Git, you have hosting services that can essentially host your repositories and files. So GitHub, Bitbucket, GitLab are probably the most well-known ones out there. And what they do, they provide web-based interfaces, backups, wikis, and another point to raise is that Git will typically integrate with a build orchestrator or a build automation tool like your Jenkins or Urban Code Deploy. And I tend to get frowns when I mention that, because traditional library manager solutions pretty much cover a lot of that kind of capability, from SCM to build to package to deploy. Well, the advantage of kind of having a decoupled tool chain, for example, Git will only do the SCM, you'd have to have a build tool like Jenkins and then an artifact repository and a deployment manager. The advantage of decoupling that kind of tool chain is that if the next flavor of the month comes around, I don't know, a deployment manager, you can simply just rip and replace that capability and add that additional functionality that will be better than the other tool. Whereas before, in a library manager solution, it's quite difficult to do that, right, without heavy scripting and customizations. So that kind of level sets on Git. So now I'm going to talk about Git for zOS. So in order to use Git on zOS, you need Git from Rocket Software, which essentially only acts as a Git client. So it's a free download. It does require Bash, gzip, and Perl. Runs on the USS, and there's SMPE and manual install options. But it's essentially its primary function is to do a Git clone from your Git branch, probably a next release branch, to trigger off a release build pipeline. And that would be triggered off by your build orchestrator like Jenkins. And what happens is that when you do a Git clone from USS, which you'll see in the next chart, it will write those files write those files from Git to USS as part of the Git clone process. So I'm going to take you through a scenario. So you've got your enterprise Git server, and you have probably your distributed or front-end teams using Git, and they've got their repositories in their Git server. Now I'm posing the idea that you can have a mainframe application repos on your Git server. There is also the thought that you could have a multi-platform application repo. So let's imagine that front-end application 1 links in mainframe application 1 repo. You could kind of combine those and have a multi-platform application repo. But for this presentation, we're going to keep them separate. So I've got my sort of my folder structure or my repo structure on the left here. I've got a screen on the left, hence me looking to the left. Where I've got my infrastructure components, I've got my backend components, I've got my messaging layer components. I've just thrown in some examples there. So let's say I now want to, I want to build those artifacts on my LPAR. I will trigger off a Git clone via an orchestrator, like Jenkins, for example. It will write those files out to USS. Or let's say I've got my modern IDE and I've just changed one program. I want to then, I can actually use my modern IDE to port my changed code and its dependencies to USS. So now I've got all of my artifacts in USS via one of those two mechanisms that I've mentioned. The question is, how do I process and build those mainframe artifacts from USS? So that's why we essentially created IBM dependency-based builds. So what we did is we took Groovy, and why Groovy? Well, Groovy is just one of the most well-known languages in the world. It's heavily used in a variety of modern tools like Jenkins and Jenkins pipelines, Urban Code Deploy, the list goes on. So we took Groovy and we created a smart build toolkit, right, which supports MVS exec, TSO exec, ISPF, JCL exec. So you can do general system automation type stuff as you would do, in JCL. Now, I wouldn't recommend you replace the JCL in your scheduler, but you get the gist. You can process and build mainframe artifacts via this capability. We also have a dependency scanner, so we can scan all of the source code, scan the code and capture the dependencies and store that in a dependency-based server and database. And then that dependency information will be used in subsequent builds. Hence the name dependency-based build, which I will refer to as DBB from now on. There's also a source migration capability, so you can essentially import your source artifacts from a dataset into a Git repository. And I've got a snippet of code just showing how that would work on the right. We have reporting capability where we can produce build reports, and you can see at the top right here, there's an example of what that build report would look like. And there are hyperlinks there where you can actually see the dependencies, both source dependencies and link edit dependencies in that report. There's extensibility as well, so you can retrieve this information from an API or REST API call to the DBB web server. And you probably are thinking, this is a bit daunting. Are you saying that we have to create a complete build process or Groovy build process? No, I'm not. I'm saying that we now have a capability called the ZApp build framework that out of the box can build assembler, BMS maps, COBOL, PL1, etc. And we provide scripts to help you integrate this build process into the likes of Jenkins and other tools like Urban Code Deploy from more of a packaging standpoint. And the idea of this ZApp build framework that is freely available, you would customize this kind of build, which is basically a Groovy DBB proc or procedure. You'll customize this to be able to match your environment needs. You will store your ZApp builds, build procedures on a centralized USS directory that will be maintained by your mainframe build administrators. And the idea is that if a developer wants to, add additional compilation palms when they build code and they're shipping code to the LPAR to then run the ZApp build process, there are configuration palms in the repo itself where they could add an additional palm. And then when they move their code to USS and then trigger off the DBB build scripts, they can move those palms as well that add the additional compilation palm, and it will add it to the build process. So the developers never have to tamper with that ZApp build proc in that centralized USS directory. So really simple, you don't have to create a build proc from scratch. You simply reuse this, customize it to your needs, and away you go. And we do have an ISPF interface. And the reason why we do that is because Git is not just for the developer. As I mentioned, I'll just flip to the next chart to show you an example. As I mentioned, Git is not just for the application developer, it's also for the operational personal people, right? So infrastructure as code has become a very, very big thing. So we don't want them to have to use an IDE. They can, still use the traditional interface to mainframe. And, as much as I don't like to admit it, there are a lot of developers out there who are close to retirement and not keen on picking up, or using modern IDEs. So this kind of ISPF Git interface does give them an option to still stick with what they know and love, just a different way of interacting with an SEM from a mainframe perspective. But obviously the ideal is that we have an IDE that we standardize on and have standard practices and processes for all developers to abide by. So back to the scenario. So as you can see, I'm just looking to the left, I've got a bigger screen on my left here. So what we're doing now is that we're adding the ZApp build config files to give developers the opportunity to add additional palms, like an additional, compilation palm or compiler palm. We now still triggering the Git clone via the orchestrator, which will write the files to USS. Or we've got the developer using their IDE to port their change code and dependencies to USS. The way you would build them is by using the ZApp build process and tweaking that to meet your environment needs, your mainframe setup. So to answer the question, how do I process and build my mainframe artifacts from USS? It's quite simple. You edit the setup build samples that are provided by IBM, and you create a company-specific DBB build process. So I think we've kind of level set now in terms of what is Git, why Git, and what is dependency-based build. So now what I'm going to do is take you through a journey. I'm going to take you through a change all the way from starting from Jira all the way through to production to deployment to production. And hopefully the demo goes on my side, because this is a live demo. So there's going to be 4 personas in this demo. The first persona I will not be demonstrating, but this is the analyst, or the role, should I say. This is the analyst who's done some automated analysis work and scoped and sized the business epics or the business requirements and user stories. I'm then going to be the lead developer who's going to come in and look at the analysis work for the requirements that the analyst has analyzed. I'm then going to create a feature branch from the Jira ticket. I'm then going to create a regression test pack using a capability called WASI Test, Virtual Test Platform. I'm then going to assign that development task to my developer, which will be me. So then the developer is going to pick up the Jira work item. He's then going to clone the Git repo to his IDE, or his local branch. He's then going to update and build a automated unit test, which is going to be a capability called zUnit, which enables me to test a program in isolation while stubbing out kicks, DB2, and core programs. I can be running that test on my own sandbox environment or on the developer. In this demo, I'll be doing it on the developer. I'll then make my actual code change. I'll build the change, and then I will run the zUnit test case load module against my module under test. I will then trigger off the code coverage to make sure I've covered the lines that I've changed. I'll then commit and push the code, as in I've done my change for that one program. I'll then run some regression analysis and regression tests based on what the lead developer has set up for me in his part of this flow. And then I will update Jira with my code coverage reports and all of the reports that, and the actual regression test report. Then the lead developer is going to check that the completed Jira tasks are good. Like, it's going to have a quick review of those, and then trigger off the next release branch, the release build. So now we're going to we've got a release candidate, and I want to trigger off the. Oh, sorry, that's incorrect. Sorry, I'm going to be merging my code to the next release branch as a lead developer. Then the release manager at the bottom left will trigger off the release build on my next release branch. That will create a release candidate package, and then we're going to schedule that package to be deployed to production. And as part of that deployment process, we will refresh, we'll merge the changes from next release to the main branch, as long as obviously deployment was successful. So let's go through. I'm now going to be the lead developer and go through that use case. So here's my Jira dashboard. This is the GenApp insurance dashboard, and which is the application that I work on. And if I go to the epic and just hover over, we've got an epic here that states identify, improve, and expose general insurance application to a REST API. Okay. And within that, we've got some tasks that have moved from analysis to build. And if I just hover over the green kind of icon here, we've got a user story. So let's click into that. So the user story says, as a support representative, I would like an API that clearly distinguishes between a customer that is not found in the database versus an actual database error to better support General's customers. So the company is called General. Okay, I can see here that Dave, who's my analyst, has done some analysis on this and has broken this down into 2 user stories. One is called, and they're listed in priority. One is improve DB2 error handling rules in the GenApp insurance application, and the other is to expose the inquire customer to an API. And if I click on the GenApp transaction, this is the actual pictorial view from the tool called Application Discovery. So this is an output of that tool showing all of the components that make up GenApp. So it's a very big application. The yellow cogs mean that these are transactions. The blue icons here are programs. The reds are maps. And if I scroll down, you can see that we've got the kind of Excel spreadsheet icon are DB2 tables. Okay, so if I just close this and I scroll down, Dave, although it says JTA, but let's just imagine it's Dave, has said, I've attached the most recent application discovery view of the GenApp insurance, and created development tasks based on the user story and my analysis work. More attachments are in the Jira tasks linked to the user story. Okay, so I'm going to click on the GenApp inquire customer. And if I just hover over the blue icon, it says it's a task. So that's how I can distinguish between tasks, epics, and user stories. And when I click here, we've got GenApp inquire customer SQL evaluate query needs changing. And nicely, there's a link to the actual source code, well, where the code needs to be changed. So if I right click, open in a new tab, I've got a direct link to where the code is. So you can see moving when SQL, let's scroll back up actually. For this SQL select query, when the SQL code is 100, we're moving 01, and for -913, we're moving 01. And they're completely different error codes. One means no data, and one means, I think, a timeout or deadlock issue in DB2. So if we're going to make this an API, that we need to sort of, make sure the error handling here is much better. So I'm going to just close that, go back to my Jira ticket. Remember, I've got my lead developer hat on. So I'm going to create a branch from here. So from the Jira ticket, I'm going to click my integration to my GitHub server. I'm going to say create branch. Right, so we've created a branch now automatically. And if I go into my GitHub, my Git repo for GenApp, you can see, oops, yeah, so we've got the zproj-17 branch just been created. So now the next thing I want to do is create a regression test pack, right? I'm going to create a regression test pack with just one test just for demonstration purposes. So how I'm going to do that is that I'm going to we'll locate the attachments. Hopefully there's the attachments. Oops. I've just seen that there's no attachments here. Oh, there's the attachments. Okay, so Dave is also giving me a more focused pictorial view of where that change needs to be made. So for LGIC DB01, which is where the change needs to be made, if I click on the transactional call graph, I can see how, if I scroll in a little bit, this is the program where we've got that error, or that error handling needs to be changed. And if I just scroll down a tad, you can see that we're doing that SQL select query from that blue arrow from the customer table. And this program is being called by LGIC US01. And if I go back up, that is being called by LG Test C1, which initializes the map. And here the transaction is SSC1. So I'm going to create a regression test to enable my developers to run the test after their change to ensure they've got no regressions. So what I'm going to do, using a tool called WASI Virtual Test Platform, I'm going to record the input to this program from the map. I'm then going to record the program arguments that's been sent to LGIC US01. I'm then going to record the program arguments from LGC US1 to LGIC DB01. And then going to record the interactions from DB2, from the actual table. I'm then going to store that in a Kix TDQ and then push that out to a sequential file to enable my developers to run a regression test, just to prove that none of the programs to prove the programs are behaving as they should be when I run this recording, and highlight any regressions, and that will enable them to do that test while stubbing out Kix and DB2. So what I'm going to do, I'm going to go to my Kix environment, and I'm going to go to Kix Cob, which is my Kix setup, my Kix region. I'm going to show you that transaction, SSC1. So we've got three options here: customer inquiry, customer add, and customer update. We definitely know it's a customer inquiry, so I'm going to select option number 1, and I'm going to give the customer ID customer 1. Right, so that's just showing you what the transaction is doing from when I triggered the transaction from here all the way through down to here. So I'm going to now record this. So I'm going to trigger off a transaction called BZUS. Which is going to start the recording and record all the program arguments between those programs and store that in a TDQ. I'm going to go back to that transaction. I'm going to select customer number 1. I'm going to select inquiry, customer inquiry. I'm going to come out of that, clear screen, and now I'm going to stop the recording. BZUE. Clear screen, and I'm now going to write that out to a TDQ, and then what I would then do is do a CMT inquire TDQ BZUQ. I'll stop it, and then I'll write that out to a sequential file with a meaningful name, like feature 1, or I'll give it a meaningful name for the developers to then do a regression test. So assuming I've already done that, so I'm going to come out of this, and I've updated this Jira ticket to say, here is the sequential file to essentially, that does for SSC1 inquire transaction. The regression test pack with 1 test is generated by IBM Virtual Test Platform and ready for you to use after you've made your change. So I'm also going to be a good lead dev, and I'm going to update the regression test execution JCL, which is in the actual repo. So I'm going to go into my repo. I'm going to expand the source code. I'm going to locate the regression test execution JCL folder. Here's the JCL. Just to quickly highlight what you have to do to run that regression test, you have to specify the load module library, the load library for all of the load libraries for that transaction, and your change module. And then you use what we call the playback file, which is that sequential file. You have to add that into this here where it says BZU play DD. So I'm going to do that for the developer. So I'm going to add that feature regression test pack. and I'm going to have commit, put a commit message, let's say regression test pack updated in JCL. And I'm going to commit that straight on the feature branch. Okay, that's good. So now I'll come back to the ticket, and what I will do is I would assign this to Joe Taff Atkins. So back to the flow. So I've done the lead developer. Now I'm going to be the developer who's going to view the ticket, make the change, and so on. So putting on my developer hat, I've come into the ticket and I can see that I can see the actual defect or the issue from the link to the source code. I can see the branch that the lead developer has created, and I can see the regression test pack for me to use after. So I will go into my modern IDE. Let's move this to the side. So this is my IBM developer interface, or IDE, should I say. At the top right, I've got my connection to my developer. At the bottom, I've got my Git staging view where I can commit code and push code. And here is at the top left is where I can clone my Git repository or Git repos. So I need to go back to my ticket. I need to locate the branch, which is here. I then need to go to my clone at the bottom right or the middle right here. And because this is enterprise Git, I'm going to clone via SSH. I'm going to come back into my IDE, and then I'm going to select clone Git repository. Now it puts all that information in there for me automatically, which is good. I'm going to click next. And you can see that I've got 3 branches: main, next release, and the one that's just been created. I'm going to be using the zproj feature branch. I'm then going to give, well, hopefully one I haven't been used. So I'm going to give my local directory, so where we're going to clone the code to, and I'm going to select finish. Okay, so now I've got my branch, my local branch, zproj 17, the remote branch. I've got my my working tree, and I've got kicks-genapp where I've got all of my source code and artifacts for that application. Okay, but I really want to have that in my zOS projects view because I get a lot of additional benefits where I can reuse test cases and so on in this Eclipse view. So how I'm going to do that, I'm going to simply go back to Git repositories view, and I'm going to highlight the HLQ for where all my application is, or the high level qualifier, which is kicks-genapp. I'm going to right click this, and I'm going to go create zOS project. Now, if I go here, you will see that I've got that repo or that branch in my zOS project view now. Good. The other thing I have to do is that I need to, IDZ needs to, or the IBM developer IDE needs to know where all the copybooks are. So what I'm going to do is I'm going to right click and go to dependency-based build and say generate a property group, which basically points to, it will generate a property group to highlight or locate where all my copybooks are for my source code. So I right click that, select this, and click finish. And that's done. So now I'm ready to start my development activities. So first, what I'm going to do is just talk you through the repo. So I've got my ZUnit folder where I've got all my test case programs to test against the source or the binaries from in the COBOL, test against the source in COBOL and the binaries that are built. I've got my BMS maps, I've got my copybooks, and I've got my Jenkins files to obviously trigger off a release build and the hotfix build in Jenkins, which you'll see after. So let's locate the LGIC DB01 program. And if I just use the outline view at the bottom left here, I can jump to get customer. And this is where we have that SQL sort of defect that we need to fix or address. So what I'm going to then do, what I would typically do is update my test case, right? I would create or update my existing test case. And how I would do that is I would right click the module that under test, or the module that I'm about to change. And I would go to zUnit, zOS Automated Unit Test Framework, and then select Generate Test Case. What has happened is that it's identified that there is an existing test case program for this module. And it's asking me, do you want to reuse that? And I'm going to say, yes, I do. And the test case module is called TLGICDB0. And the test case description is that this program tests LGIC-DB01, right, which is the program that we're about to edit. Right, so what I would do, but for time reasons, I would open up this test case editor, and I would create a stubbed DB2 to return SQL -913, which is where we need to make that change. And then I would say that I expect the program to return 02 in the CA return code. Right, so I'm doing test-driven development. I'm updating my test case first before making my change. Now, because of time reasons, I've already done that. So that has already been completed. So I'm going to close that. So imagine I've already updated the test case. I'm now going to make my code change. So when -913 moves 02, and I'm going to save that. And now you can see that there's unchanged artifacts or unchanged source in my Git staging view. So I'm done. So what I want to do now is I want to build my test case program, and I'm going to right click the program which was called under zUnit called TLGICDB0. So you can see it's put a T at the beginning of the actual test the program that we're trying to test. So I'm going to right click this module. I'm going to go to Dependencybased build and then configure user build. And here it's going to ask me, what system do you want me to transport and build this code on? I'm going to say my developer, which is WTS47. The next question is, what build script do you want to use? So I'm going to click Browse. And if you remember what I mentioned before, this should be in a central USS directory that is maintained by my build administrators. So I'm going to locate, oh, I've got this Zoom thing in my way. I'm going to locate that ZApp build, that customized ZApp build directory, and I'm going to select the build.groovy-proc to build my code. It's then asking me, please enter the sandbox folder. So this is the folder where we're going to be moving all of our code, our test case program, and then building that code from USS. So I'm going to select a USS directory called GSC user build, and click OK. And as part of the build process, we create some temporary data sets to compile the code, so moving the code from USS into a data set before compilation. So I'm going to give it my HLQ at the end. So I'm going to go to next, accept the defaults for now. I then have to add, you can see at the bottom, we've got a command. So this is the actual DBB command that will be executed behind the scenes. There's only one thing I have to add to this command, which is --a, which is kicks genapp. And that's the high-level qualifier for my overarching, basically for my zOS project, so kicks -genapp. If I click OK and click next, and I expand, it will tell me it's going to be porting the zUnit test case program to that directory, right? And I could also specify some of those overrides from the application config file. Let's say I wanted to add an additional compilation palm. I could specify that in here and port that to the directory as well before compilation. So I'm good. So I'm going to click finish. I think I'm good. Let me just double check one more thing. Yeah. right? And then it's saying that, because I already tested this yesterday, it's saying that you've got test case code there already called TLGCDBO B0. Do you want to override? Yes, I do. And now if I go to the console view, you can see that's the DBB Groovy command we've executed. And we've got a clean build, right? So we've got clean build. And if I expand the details tab, I can also see the listing here as well. And I could also show you the temporary data sets, but for time reasons, I'm just going to have to move on. So now I want to build the actual program that I changed, LGICDBO1. So I'm going to right click again, go to dependency-based build. And you can see that because I checked this before in the previous build, I don't have to re-enter all those values. I'm going to click next, accept the defaults, don't have to re-enter these values again, click next. And if I go to the base code, we would have selected that program. And I've also checked, discover the dependencies to load for LGICDBO1. So also pick up those dependencies as well. You can click finish. You can see the build command's been executed, and we've got a clean build. And again, I can expand the details tab and see the listing. Okay, good. So I'm happy. What I will now do is I want to run my test case, my ZUnit test case code against the load module. And how I'm going to do that is by right-clicking on the corresponding ZUnit configuration file, which is called LGICDBO1. And if I right-click on that, do a dependency-based build, I'm going to click accept the defaults again, but this time I'm going to add another build option called -cc. And what that will do is that it will run the test case, but also bring me back co-coverage for that test case execution. So I'm going to click next and then click finish. Okay, brilliant. And I could go into the USS directory and look at the results of the actual unit test if I wanted to. And I've got the actual report, the actual code coverage report. And if I jump into the get customer info section of this code, and if I scroll down, I was able to test this code and cover this code without DB2. There was no DB2 called. The test case program stubbed out DB2. There was no kicks involved because it also stubbed out kicks whilst verifying that the program did what it was supposed to do. So I can export this code coverage report. Just imagine that I've already done that. And I'm happy to say that I can commit my code, add my code, add a commit message, call it zproj SQL change complete. Okay, and then commit and push. That's done. And then what I would then do, just quickly, if I'm probably running short on time here, but the code has been now being pushed to the feature branch. I can then run my regression test to make sure I haven't broken anything. So I've got my regression test JCL. Let's just untoggle this off to a comment. I want to put in my load library location, which is dmjta1.load. I can then run this regression test. And I've got a code coverage report for the entire regression test, for that entire customer or that transactional journey, without kicks running, without DB2 running as well. And I can export this regression test report if I wanted to. And if I go into the regression test output, just double click this, you can see that everything is okay, everything was normal. And we were able to do all of these kicks commands and Kix links, etc., without Kix running. So we verify the programs were doing exactly what they were supposed to do after the change. So I haven't broken anything. So good. So I'm going to go into my Jira ticket. Let's move this to the other side. I'm going to go into my Jira ticket. As a developer, I might add my regression test report into the ticket. I also may want to upload those code coverage reports as well. So let me bring that out. Just give me 1 second. So I'm going to just quickly pull those reports into. So you can see I've got my unit test report coverage and I've got my regression test coverage report. Right, and I'm going to flip hats. I'm going to flip my hats to be the lead dev and then check the Jira tasks. So I'm going to check the Jira tasks, make sure I'm happy, and then I'm going to just do a refresh. Good, and from here I can see that the commit that the developer just did is actually linked to this Jira ticket. So I've got that traceability, and I can click on that link and it'll take me to the code and show me what Joe's just done. And then I'm happy to now go ahead and trigger off a pull request where I will merge my changes from the zproj 17 branch to the next release branch. Right, and that merge will require an approval or an approver. So we're just going to assume that got squared away and that's been successfully done, just for running short on time. So now what we're going to do, the lead developer has approved the changes and has merged the code to next release branch. I'm now going to trigger off a release build pipeline, which will essentially take that change code, package it, test it, and then I will then schedule deployment to production. So I'm going to go into my Jenkins dashboard and I will trigger off a build now. So what Jenkins will do is that it will identify the deltas from the previous successful release build, do a Git clone for my develper to write those files to USS. We're then going to build and compile and link those modules, and I'm going to be using the optimized palms that come with the latest, that comes with version 6 compiler, so the ARC parameters. Hopefully that gets done soon. Should be quicker than that. Right. And then we're going to package those built artifacts and store them into Urban Code Deploy, which is my deployment manager, as well as artifact or binary repository. And then we're going to trigger off the UCD deployment. So if I go into my UCD environment, we should be deploying to test. And if I go to history, you can see that I've got a deployment to test running. And if we view that request, and just expand the deployment process steps, you can see that we are downloading those artifacts to a test system, to our test LPAR. We're then deploying those binaries to the Kix load library. We're generating a load module list, a list to do the Kix new copy. We're generating the DBRMs to the bind, triggering off the bind, doing a new copy, and we're also doing our API service tests. And if that would have failed, it would have automatically created the Jira ticket on my Jira backlog, a defect ticket. So what does that mean? That just means that package has been thoroughly tested, and I'm okay to now schedule this to be deployed to production. But before I do that, I want to create a snapshot. So I'm going to click on the snapshot button here. And then I'm going to create a snapshot, and I'm going to call this snapshot version 1.0.2. I'll just say SQL change completed. All right. Then I'm going to add that release candidate, which is 76. And what does 76 correspond to? Well, that corresponds to the actual Jenkins build, which will send a release build pipeline, right? And that's been completed successfully. So I'm going to pick 76, and I might have an opportunity to merge with a hotfix package that may have just come in. So we'll do that as well. So I can now go back to my GenApp application process, and I can now schedule this deployment to production. I'm going to choose the snapshot, which is version 102. Could give it a message. Let's schedule this for 10:05, and I'm hoping to finish. And then once I've scheduled that to production, it's not as simple as that, because now I've got an approver, which will get an email saying you now need to approve this. And I'm going to be that approver and say, this is just a GSC demo. And click reject. Right, so if I go back to GenApp as an application, you'll see that the approval failed for deployment to prod. So that was a lot to cover. I think I've done okay for time, but I would just say, just to summarize, you know, hopefully what I wanted to get across is that you can have a single enterprise tool chain, you know, that manages both modern and traditional mainframe artifacts, that, you know, builds obviously agility and quality into your mainframe process, and hopefully, you know, attracts new talent, new generation developers to our platform. That might have been a lot to show in an hour, but we do help clients along this journey, and we do have free advisory services to help clients migrate their first application to Git. So there's a lot to cover there, but I'll just say thank you for listening. If there are any questions, please feel free to answer. I think we've got ask them. I think we've got 1 more minute. In the meantime, there is a feedback QR code, so please do provide your feedback. Dennis, anything you want to add before we pass over to questions?
No, well done. Thank you, Joe. There's one question about production backout handling. So it really depends what strategy you're picking. So if you pick the move forward strategy to deploy a hotfix to the production environment, then it's always going forward. UCD itself has the capability to roll back a certain package and to restore the previous state. So certainly that would be possible. The UCD package itself has information underneath, like the Git hash, so that we can also trigger off some actions in the Git repositories, depending on the branch layout you have in there. So it's difficult to answer in a minute, but for sure we need to have the traceability. The package contains the link and the traceability information to go back to the GitHub repo and to manage that.
Thanks, Dennis. Probably overloaded. Lots of information there. So my email is on the screen. So if you want to do a more focused session, please feel free to reach out. Stuart, I'll pass back to you.
Thanks, Joe. Okay, yes, that was a lot. That was an awful lot. So session feedback is for AL. For everyone that's attended, the session has been recorded. We will be posting them in a period after the conference is finished. So there will be an opportunity to watch all of that again and maybe consume a bit more. And as Joe says, his contact email is there on the slide. But for AL, for your feedback, and enjoy the rest of the conference. Thank you, Joe. Thank you, Dennis. Have a good day.